welcome to this presentation. This presentation itself is on data presentation. Data here mean numerical values and other information that we collect during any type of study. Now the question is how we are going to represent this. We will see in these different ways of representing data in the form of text, in the form of tables, in the form of graphs, and compare between them and which one to uh, consider at what point of time. That also will be discussed. We'll also take the support of Excel wherever possible for the representation of data or for drawing of the graphs. It does not mean that we cannot use some other softwares for drawing of graphs or preparation of the tables, but this goes quite handy and is available to most of the people. I mean, most of the people have access to Microsoft Excel, and so most of our discussions, as and when necessary, will be based on Microsoft Excel. So, welcome. This is Professor Dipujyoti Bhattacharya from the Department of Statistics, Assam University, Silchar. So, way to my presentation. So, let us look at where do you want to present your research data. So, suppose you had made some study, you have collected some data. The first and foremost question that where you are going to present it. So, whether you are going to present it in a research article or any report, whether you are going to make a seminar presentation, oral presentation, where you need to display the data in the form of tables and graphs, or maybe in the form of text information, or you are to make a seminar presentation, which is a poster presentation. In a poster presentation, the researcher or the incumbent generally prepares a poster in a particular flex or a particular page of length, say A3 or more. So accordingly, this particular display has been made. So all the information of the work has to be displayed in one poster. So the poster should contain the objective of the study. It should have the introduction part, have the objective of the study, discuss the methodology, different analysis, and also have the presentation of those analysis in the form of results, declaring the results, and so on. So these are the two things that we are going to cover in this presentation. That when you want to present your data, whether you are preparing for a oral presentation, whether you are preparing for a poster presentation, or whether you are preparing a research paper or a research report. Now let us look at the purpose of data presentation. Data presentation is a visual way to look at data and to make some interpretations from that particular diagram. This basic purpose is to turn the attention of the audience to that part of the presentation where you want them to see. Now, in a graph or in a table or even in a text telling about some numerical information, what we want is that the viewers or the listeners should get attached to some particular part where you want what you want them to show. They should get interested on that particular aspect, not on some other aspects which is spread across the entire sheet or entire screen. This actually help you to complement the inferences that you are making on your study. So data should be visualized in a way, or data should be rather presented in a way, so that the onlooker actually comes and visits that particular place or looks at that particular place, which actually helps you to make an inference on your work. So this makes the role quite important. And now let us look at these points to remember when you make a data presentation. Don't force your audience to do mental maths and draw inferences based on your data. Now you show something and then you keep something for computation of the audience. That is not a good thing. We will actually take up some such issues. The audience is interested in knowing the inference of your work. That is what is important. That whenever you make a presentation, first and foremost thing is that you tell the objective. This is the objective of the study. An introduction actually gives you the reasoning of the objective, that okay, this objective is very important, and that comes from the introduction. So introduction objectives gets its energy from the introduction. Now once the objective is spelled out, then the people are generally interested in getting that, okay, these are the objectives, so what is the inference on that? So you tell that, okay, rain, if there is a rain, and after the rain, if the match starts again, then the performance of the players goes down. That is the to your objective is to find it out or to establish this fact. Fact or not fact, actually, once you established it will become a fact. This is what you hypothesize. Now, the audience generally will want to know that, okay, what is your inference after that? Did you really find that after rain, the performance of the players goes down? Or you find that after rain, the performance of the player remains the same, or it gets elated? So that is where the object, where the interest of the audience lies. Some people might be interested in looking at the methodology also, but these are very few people. They are those people who are interested and working in the same area. So they would be interested to know how you actually reached from your to your objectives uh, through the data or through the methodology that was available to you. But most people, even at the very beginning, those people who are interested in the methodology also first want to see the inference. What is the inference that you drew? Highlighting the important findings of your data in the form of a table or graph so that inferences can be easily drawn. So once the particular individual is interested in the inferences, he or she wants to see that how you infer about the objectives. And then often results are displayed in the forms of graphs and tables. So those graphs and tables should draw the attention of the onlooker towards those points where inference is very vividly being expressed. So that is the purpose of data presentation. Now let us look at that different forms of data presentation. Data that you have can be presented in one of the following forms. So either in text or in table or in graphs. So let us see these points one by one. Now, data in the form of text. Unless there are too few numbers, data shall not be placed in the text. Sometimes it happens that we have very few numbers to tell about. And in that case, text is the best thing to do. Some of your studies in business research and in other type of social science research might ultimately take you to very few values. In that case, drawing a graph or drawing a table to represent the findings of your study, which is in the form of numerical information, is not a good thing to do. Rather, you can express them with the help of text or in a paragraph. If the data comes with a noun, then use numerals. Experiment 5. So experiment is a noun, 5 is a number, not like experiment 5. Group 10. So you are specifying a particular group, group 1, group 2, like that. So these type of things when come together, that is a numerical preceded by a noun. So there should be, a noun should be in text. Obviously, you cannot write noun in terms of numbers, but the corresponding number should be in the form of numerals. If the data has a unit of measurement, express them as numerals. So suppose you have something like 5 centimeters. So centimeters should be written as CMS, or you may write full centimeters, but the corresponding number should be in numericals only. 75%, not 75 and then percentage symbol. So these are some important things you have to remember when you want to tell something about data in a textual form. Now, data in the form of text to be continued. If the numbers are not used with the units of measurement or with noun, spell out the number if less than 10. For example, there are no nouns to precede the number. Just you want to tell a number that the experimental resulted into 10 deaths of amphibians in a particular collection, etc. Then tell it down in terms of numbers. If the number is less than 10, then express it in text. For example, 7 treatments, threefold, like that. But if it is 10 or more than 10, then express in numbers. Use numerals if it is 10 or above. A sample of size 324, not sample of size 324 in spelling. Not that way. Numbers with decimals shall be always numeric. Obviously, 0.25 or it should be written in like this. Many of the softwares you will find that when you do the calculation, if there is a something decimal, they give it in this form, 0.25. Now, 0.25 and 0.25, they are same, but when you present it in a textual form or when you put it in a paragraph, these values, then this should be numericals number one, but it should be preceded by zero. Even if there is nothing like that, if the software gives in sometimes p value often is written without zero, like it is written like point 012 p value. We'll see later on. So not like this. You put a zero before it. Software may give you this part, but even then, when you put it in the paragraph form, you write in this way 0.012. Okay. Thousands should have separators. So this is 10,000 people. It should be written with separators. When you express them in numericals, you have to express them in numericals, or better to express them in numericals. But you put a comma in between so that things can be separated. So these are some important things you need to remember when you represent a data in the form of text. Let us proceed forward towards table now. How to represent your data with the help of table. So this we have already text we had discussed. Now we come to table. Tables are the best way of showing structured numerical information. Okay. Now in a table, let us see different parts of the table. So this is a table, say some available values are there. So these are, so now let us see what are the different parts of the table called. Now, this is the table title, which actually gives you an idea about what thing is there inside the table. Just if you look at the table, then you might not understand what are the values representing. But here it tells race-wise population of the different states. So, three races are considered, and the population of three different states are given. And then the title actually express about them. These are called as the column heading, state 1, state 2, state 3. So these are the columns. So this table has four columns. One column does not have any data, but other three columns have data. So these are called as the column headings. Then comes the grid lines. These are the grid lines. These are the row heading. Race 1, race 2, race 3. These are the row heading. This is the location of the data collection source, that the source from where you have collected the data. If you have some comment to place, then you can comment below the source. Now, both these things like source and note, they are generally written in italics so that they can be differentiated from the text that might appear below the table. So these are the about the tables. So these row heading, column heading, all these things. This we will refer often, and we need to actually uh, develop or draw the table with these all accessories. Now, golden rules for table formation. Let us look at this. First, title of the table shall lead to the main findings. Okay. So, only essential data shall occupy the tables. So, in the table under, say, a particular row and particular column, that in a cell, you may have several type of information to represent. All of these might not be important for your inference. Only provide those values which are essential and where you want the information of the means onlooker to be drawn towards. So those things should be there in the table. Use significant digits only. For example, suppose it is money methods, then you give two digits after decimal. Uh, so this way, only significant digits should be there. Avoid using too many grid lines in the table. Avoid unnecessary text in the uh, vertical stub and in the horizontal stub. Horizontal stub means those table column heading and row heading. Display the data in chronological order, either in terms of time or in terms of alphabets. So we will see some such examples. Use thousand separators. We had already discussed in terms of numbers. Align numbers with respect to decimal places. So all the decimal places should be aligned together. That means what is before the decimal, that should be in one side, after the decimal in one side, and all the decimal points should be aligned so that we can actually very quickly read into the data. Do not leave data cells empty in case some information is not available. Better to write NA, and NA shall be explained that the data not available or the data does not arise, something like that. Here, actually, there are two tables so where we bring in all these things which we have discussed and point that we discussed. That is there. Now, initially, when you look at this, it seems both the tables seems to good. But let us look what are the things in the incorrect table. Now, first thing is that you see the name is there, title is there. So that is what is necessity for a table. Title is there, fine. But this title tried to actually define something. Employed persons per thousand in Indian labor force. So labor force are those people within a particular age group who are ready to work or available for work. So that is the, and those actually employed divided by total number of persons available for work divided by 1000. So that is the labor force. Now here you see in the table itself, the author tried to give the definition of employment condition. Instead of that, if you look at this one, the table, correct table, there you find that table 1 number is there, employment rate in India 2011-12. Now here you see first table, the wrong table. The year is not there. So it is difficult to understand the data representing which time zone or which timeline. But here it is very clear. Now employment rate. Now you may tell that someone may not know about the employment rate or how the employment rate is defined. So you see, I have given a note, or the author has given a note, employment rate, and below that one, and below that in note there is written the number of employed persons per thousand of age 15 years or above. So this is how we actually make the table title very short. You see, table title has become very short in the correct table than what it is in table 1, and actually gives more information. Any definition is there, term is used, employment rate is explained below as well. Now, let us look at the next point of discrepancy. So you see these column headings are there. These column headings are like plain text. So it does not attract your attention directly. But if you look at the correct, and also you see there are lot of grid lines are there in this particular table. Now here you see there is in the first table, incorrect table, no such total is there. So if you want, someone wants to see that, okay, let us see how many males are employed and how many females are employed, etc. Or say these things are not there. So this comes with here, the overall employment rate is shown. It's not the total, it's overall employment rate. So that you can understand that, okay, overall employment rate, you may speak that this is an average. So 751 is the average number of average employment rate, and you see not literate, below primary, primary, and even middle school level, they are having less number of people, below the average number of people who are uh, uh, employed. So you see one interesting thing, that educated people are finding it difficult. Say those who are secondary 660 employment rate, higher secondary 587 employment rate, diploma 631 employment rate, but with graduation 715 it has increased little bit, but less than the national average. PG and above 775 of them are employed, which is above the average. It is interesting to see that people who are in the lower group with lower level of education have higher employment rate. Now, these actually, all this type of interesting conclusion, you can only make if you get the overall figure. And that's why overall figure should come at the bottom. It should be very vividly defined. As you can see, we have taken a bold text to explain all these things. So this becomes very vividly defined. So what is the takeaway, that either the total or the overall average should come at the bottom of the table, so that things within the group can be compared. Now you see, if you compare the employment rate of males and females, males have a very high, almost thrice the employment rate of the females. And then you see the females actually, both in case of both males and females, the people with lower education are more employed. So you see below primary and no, illiterate people, even in case of females, are more than the national average. So these are some findings which we can actually see because of the last table. Now here is the source which is not expressed in table number one, and then we have note where we actually give a description of anything within the table which we feel that needs to be described. So this is how we actually can make a good table and a better table from the data. Also, you can see in the correct table, not many grid lines are there. So having many grid lines actually make your table dirty. So reading might become a little bit important. What people do these days, they color the rows alternately. One row is say green in color, a light green, so that it does not disturb you to read the text. The other one will be like light sky blue, then once again green, once again sky blue, once again green. In this way, alternately, it's green and sky blue and very light in color so that the reading of the text is not disturbed. And this is how the table has been drawn. Okay, now let us see this interesting putting stress on tabular data. What I mean to see is that I want my onlookers, I want my viewers to get interested towards particular part of the table. Now, when you are presenting before a audience through a PowerPoint or similar any type of software, presentation software, then you can actually do this. Data when presented in table shall highlight the values that you want your audience to look into. The highlighting shall be done either by color or through animation or by a pointer. Now we go to some examples on that. For example, this. Now here you see this, assume that this presentation you are making in a particular table. And now here in a particular presentation before a live audience or in a maybe in a video recorded message, there you want that the people should actually look at economy rate of T20 cricket and economy rate of ODI. These are some regression results that are being displayed on cricket analytics, and actually economy rate in T20 and economy rate in ODI, these two things are significant as evident from the p value last table. That means this table here we get the this significant. This is also called as the p value. Now, p-value will tell that these variables, these 1, 2, 3, 4, these variables are significant or not. 5 variables will be significant or not. The condition is that at 5% level of significance, the p-value should be less than 0.05. I see this is not less than 0.05, but this is less than 0.05. This is not less than 0.05. This is less than 0.05, and this is once again not less than 0.05. That means this economy rate of T20 and economy rate of ODI, these are actually significant variables. Now I want my onlooker to actually look at this. So you see, I had used color here so that the table, these two variables look different from the other variables or data in the table. And also I use a pointer here, which is blinking. As you can see in the left side, I am using a pointer, which is blinking, indicating that this is what is to be looked into. So this is how you can actually make a stress. Now, if you are making it in a report, you are putting it in a printed form, then you can use the color. Obviously, your point, you cannot blink it there, but you can use the arrow and you can use the color to make the people look at these particular two rows of data. Okay. Now, title of the table. The viewer generally looks into the slide from top down. That means from they start looking from a slide from top and then come down. So a clear title should help the viewing a table. It is better to put the title should come at the top of the table, not at the bottom of the table, because when people read, they read from top to bottom. It is better to put the conclusion of the table in the title itself. This shall be followed while writing the paper. This shall not be followed while writing the paper. Means when if you make a report, when you write a paper or a report, you should not put the outcome of the table in the title. But if you are making a presentation, then you can do this. Let us have this. Now these are two things in which This is, you see here, the author has computed the deprivation index of some districts of Mizoram. Deprivation index. He wants to display the value. He or she wants to display the value. So he gives the title table showing deprivation index values for different districts of Mizoram. Table showing deprivation index values for different districts of Mizoram. So accordingly, this person has given these values. So 0.21, 0.34, 0.22, 0. Like this, these points are expressed. So there is a zero before the decimal also. This is fine, nice. But look at this. Mamit and Langtpai are the most deprived districts of Mizoram. Then gives these values using a pointer also. Now, this is for the purpose of presentation. So, blinking pointer is okay. No issues with this. Now, here what happens from the title itself, you understand where to actually look. This deprivation means higher the value, higher is the deprivation. Otherwise, in this table, what will happen? The onlooker have to search the values. Okay, this is okay, small. Okay, this is one, and then okay, more than 0.5. Okay, this is one, and has to find out the outcome which you want to show. Here, what happens in the table itself, first thing is that the title is there, which is giving a description of where is the inference of your study, and then also you may have differently colored or a blinking arrow or a blinking circle around the values so that people get interested and look at it. Okay. So we now go back to uh, just 1 minute, sorry. Okay, so we come back here. So we have seen about the text, we have seen about the tables, and then we will now go to graphs. We let us see the graphs and how graphs should be drawn and how graphs should be represented. Now, what are graphs? Graphs are visual representation of some numerical information. Data handling software like Microsoft Excel, Elida graph can be used for drawing these graphs. Now, these softwares are not actually statistical packages. They are some softwares which can handle data, which can be used for numerous other purposes. Elida graph is basically for the purpose of drawing different types of graphs. And some packages are there which are proper statistical packages like Statistica, SPSS, and Systat. These are actually softwares in which you can display the graphs. Statistica is one particular software I would recommend for drawing graphs because it has large number of options. There are some programmable softwares also where you can write some codes and get the data represented in the type of graph, and you can have lot of control over the graphs, where you want to put the title, where you want to put the text, where you want to put the x-axis title, y-axis title, how much should be the font size, and many other things. They are very nicely handled in R, SAS, and Python. By the way, R has become more popular for statistical analysis, but you can do many such calculations also in SAS and Python. But then R has free, Python is also free, freely available, can be easily downloadable, and all the things, all the type of graphs that you have in statistics can actually be drawn with the help of R and Python. So these are the advantages why R and Python has become very popular of late. So these are the different soft options available you for drawing the graphs, because drawing graphs with the help of pen, pencil, color pen, sketch pen, etc., highlighter, etc., those days are gone. Means everyone produces graph in computers only. So these are some of the resources for drawing the graphs. Now let us look at very quickly about some common types of graphs, so which indicates that there are bar diagram. Now bar diagram actually shows different categories, and these are one-dimensional diagram. The categories are represented along x-axis, and the values taken by the categories are represented along the y-axis. Then comes the line diagram, which is actually having some generally a time variable along the x-axis and the numerical values along the y-axis. Numerical values coming from a particular entity is connected by straight line. Coming from another entity is connected by another group of straight lines which are colored differently so that the things can be differentiated. So this makes comparison very simple. Also, if you don't want to compare, you have one particular line, and with changing values of x-axis, you can see how the value of represented along the y-axis changes with time. Then you have the pie chart. Now, in a pie chart, actually there are different groups, and so there are different components which has some numerical values. The entire value of all these components, they make a circle, and the values are represented by the pies that they make at the circle. The area of the pie is proportional to the value it represents. Lastly comes the scatter diagram. The scatter diagram is having values along the x-axis as well as along the y-axis. So both are numerical values, and their meeting point is represented by a point. Scatter diagrams helps us to understand the relationship between two variables. So these are some common graphs. There are several other graphs that are available. Many graphs are innovated these days thanks to the availability of statistical software. So these days there is an attempt made to represent graphically many things, and so newer and newer graphical techniques are also being introduced. Now let us look at this and try to understand what are the different parts of a, or what are the different components of a graph. As we have seen in case of table, different here we actually will also see the different components of a graph. Now first, this is called as the y-axis title. So this is the title of y-axis because the corresponding axis is the y-axis. So these are called as the tick marks. You see in the y-axis, there are small marks. These are tick marks. This actually helps us to scale the axis corresponding to some numerical values. They are scaling. So you can see this graph along the y-axis. The value starts with 0 and go up to 10,000. So this is how the tick marks. Then you see this value. These are called as the data labels. When you draw the graph, you may want to put the data level also mentions the value of the variable that the graph represents, or that part of the graph represents. That data you want to show, in that case you can put the value here, and this is called as the data level. These are called as the grid lines. You see, grid lines are generally very light in color than the color of the uh, other components of the graph, so that you can easily differentiate them and can see, and also this helps you to read the data better. Two bars very close to each other can be differentiated with the help of the grid lines. So this is why grid lines are used, but many a time you can produce graphs without grid lines also. And now comes the graph title. As you can see, it comes at the center, at the top of the graph, so that it can give you a vivid description of the graph title. After that, here we get the legend. The legend is actually if you have multiple number of categories to be replaced here. As you can see, this is the number of blue colored bar is representing number of companies, and red colored bar is representing number of companies having research and development wing. Now, as you can see, though with year the number of companies had an increased, but I think some companies got closed by that time in 2005. But other than that, you see there is a increase in the number of companies, but the number of companies with research and development has not increased much. It is very negligible. So compared to this, so but then we can compare it. If we have the same color, it would be difficult for us to read the data. So these are differently colored, and that what each color represents, that is actually placed in the legend. So legend gives a description of the same. Now, many a times we collect the data from different sources. So source of the data should be mentioned. Source of the graph should be mentioned at the bottom of the data. Now, lastly, we have the x-axis title. X-axis title expresses or describes what is represented in x-axis. And these are called as the levels of the x-axis. These are also called as scaling figures. So here we have this side we have, these are the scaling figures. Let me see. So these are the scaling figures for y-axis, these values, and these are the corresponding scaling figures along the x-axis. Now these scaling figures are generally some light color is used to represent them, that they are so that they don't disturb the remaining data or attract the attention of the reader towards the scale values much. Only when they need it, they want to refer to it, at that time it should be present before them. So actually what happens whenever you draw a graph, the darker colors will attract the attention more, lighter colors will attract the attention less. This happens always. You may tell that, okay, this is relative term, some people may get attracted more towards the lighter color. That is the fine. But the thing is that that is the mandate, or that is the tradition, that whenever you have data to be represented, and whichever data is represented in graph, where you want the attention of the reader should go more, where actual values are represented, those should have darker color than the other accessories. So um, this is how the thing is been described, or the thing has been placed before. Okay, now let us look at forward, and let us see some things which you will not see much in other presentations. First, let us look at animation of charts. How can we animate a chart? If we are drawing a chart, sometimes for the better purpose of better representation, sometimes for drawing the attention of the readers, we might want the readers, or we might want that our graphs goes in an animated way. For example, this is actually a GIF which is downloaded from some website. It might show you which time how a thing changed. So let us look at this orange colored rectangle. So that is a bar. So you see, with the time, the orange rectangle, which was much behind red and blue rectangles, took a lead and went up. So some such things, if you want to show, you can use animation. And presentations are all about how you can make it more beautiful. Now, here are some values, some districts, hypothetical data, some rainfall. In the three districts are given by this. I want to represent this data. Obviously, I can draw three line diagrams. One line diagram representing district 1 along the x-axis. So you see along the x-axis what I have taken. Your x-axis is representing year. So I have the x-axis title. These are the scale values. It is representing time. Here I have the y-axis title. You see this is the y-axis title. What I am representing along the y-axis, these are the numerical values of the amount of rainfall in numerical, represented numerically. So these are the values. Now, actually, we are now plotting the graph for this district wise. So already you see legend is present here. So legend is giving me an indication that, well, we will have blue rectangle, a blue line representing district 1, red line representing district 2, and green line representing district 3. Now you see, this is the blue line, that is district 1. So you see how it has gone up. So till 2000, there was an increase in rainfall in this district. And then there was a fall due to some reason in 2005. And then there was an increase. So you see, data is not of all the years, but with a gap of 4 or 5 years, sometimes uneven also. For 1991 to 95, then 3 4 years gap, then this 3 years gap, then this is 2 years gap, then this is 5 years gap, then this is 5 years gap once again, then this is 3 years gap, like that. So accordingly, take these values are represented. So this is the first district. Then we go on, we get the second district. Then we go on, we get the third district. Now, if you want to see only first and second, so first and second, you can go see this way, all of them together. So you can see this. So this is how we can actually have these graphs. Once you have the complete graph, you want to switch off. So now what happens? You see, this graph is there. So we have all these districts. You can decrease also. You can increase this. Now, let us see how we have produced this. What is the technique of producing this? Now, first you draw the graph in Excel. After drawing the graph in Excel, you export it to uh, PowerPoint. So you paste it not as an image but as a graph, so that the data available in the Excel file in the backup is actually controlling this graph as well. You make a change in that Excel file, you will find the change in the graph. Now here you come under animation. There is a you select this and come under this animation tab. You will find that there is an effect option for that particular graph. So you just select the graph and come to animation pane in your package PowerPoint, and then you'll find that there is an option. Once you right click here, remove, timing, all these things, there will be an effect option. So if you click the effect option, this will come you. Now here you come to chart animation, and in chart animation there is a by series by category. As one object, then and there will be no animation. Entire graph will come together. Then you go by series and click on OK. And once you do this, then you will find that well the graph is represented in terms of series one by one. So this is how we can use this. Okay, let us look at this. When graphs shall not be used. So this is very interesting because generally we actually say that graph shall be used, but there are certain situations where you should not represent the data by graphs. Which are the situation in which you should not represent the data by graph? Comes up here. First, if the values are very dispersed, that is more scattered. That means some value very large, some value very small, some values in between. Now, when you draw this graph, it will create an illusion because some very large values will actually control the scale. The graph will get designed itself in such a way that it can adjust the largest value. So values which are moderate or values which are small looks to be so similar. Let us not see much difference between the moderate and smaller values. So in such a case, it is better not to represent them by the ordinary graphs. If you have some other ways of representing, then you can think of tabular form sometimes may go better in this regards, where you can arrange them in terms of the magnitude, and then you can see which are the states or which are the entities which are having very high values, which are the entities which are having moderate values, and which are the entities which are having very small values. If you have too few values, so in case the values are very few, then also it is not beneficial to represent them with the help of graphs. Too many values, if there are too many values in a graph, it looks very clumsy. So it looks overpopulated with observations, data, and along with the dots or bars, whichever you have, you also want to put the value levels, that is data levels, then it looks more clumsy. Really, you should avoid those. And very little variation, nothing much to display. For example, suppose I have asked a question to a large number of people, answer to which is either yes or no. Now I want to represent them in a graph. A appropriate technique can be a pie diagram. So if you draw a pie diagram, you can actually tell how many people are telling yes, how many people are telling no out of the total component of people. Now, if you draw this graph, very good. But what happens if say all the people are telling no and all the people are telling yes, or very few people are telling no, rest all of them are telling yes? In that case, if you draw a pie, the pie does not look nice. It looks like a color a circle of same color rather. So in such cases, graphs creates distorted views. So let us stop today here. This is the first part of the presentation. So second part will take up in our next video, where we will actually deal with some such examples collected from different research works of other authors, where they had made a mess with graphical display and has made graphical display where they should not actually draw the graphs. So I hope that you found the video interesting and informative. Thank you for watching the video. Please keep waiting for the next part of this video on data presentation. Thanks a lot.